Hi guys, so we are starting with a logarithmic function. So when we have a logarithmic function, the first thing that we want to do is we want to find the points of the inverse function. So the inverse of a logarithmic is an exponential function. So we're going to take the log's base, which is 2, and then raise it to the power of x, and this will give us the exponential inverse. So I'm going to use my main points that I'm always using, -2, -1, 0, 1, and 2. And what I'm going to do is I'm going to plug them in. So I'm going to get 1/4, 1/2, 1, 2, and 4. So in order for us to write the x and y coordinates of the logarithmic function, we are going to swap the x and y values because the exponential function is the inverse. So I'm going to rewrite this as 1/4, 1/2, 1, 2, and 4 for my x values, and then -2, -1, 0, 1, and 2 for my y values. Lastly, I'm going to represent the stretch by multiplying the y value by 3. So I'm going to rewrite my y values as +6, 3, 0, 3, and 6. I don't know why I did that. I'm sorry. It's -6. Hello. Yeah, -2 times 3 is -6. -1 times 3 is -3. 0 times 3 is 0. 1 times 3 is 3. And 2 times 3 is 6. Whoops. Okay, so now I have my coordinates. So I got 1/4, -6. So I'm going to go over 1/4 and then down -6. 1, 2, 3, 4, 5, 6, my first point. Let's see, 1/2, and then we're going to go down -3, 0, 1, right here, 1 and 0, 1 and 0, so it's hitting that right there. 2 and 3, over 2, up 3. Let's see, and 4 and 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, so here is the graph of this exponential function. So now for this one, if we're looking at our domain, remember our domain is all of our x values. Alrighty, and so notice how on this one, it's only really going past everything before 0. So for our domain, we're going to write it as x is greater than 0. Now for our range, notice on our y-axis, we're going all the way down and all the way up. So that's going to cover all of our bases. So for our range, we're going to call it all real numbers. Our y-intercept. So now notice this graph isn't even going through the y-intercept. We don't have any translations that have been moving it left and right. So if it's not going through the y-intercept, we're going to write none. Lastly, our asymptote tells us where our graph doesn't pass. So it's almost like a bridge troll. So we look at our y-axis right here. Notice how our graph is not passing our y-axis. So we have a vertical asymptote at y equals 0. Next, we're going to be discussing how the graph compares to the parent function. So here, all we really want to do is see what's going on over here and over here. So in front of our log, that's going to tell us if we have a stretch or a shrink, or a compression. We have 3. So since it's a whole number, it is a stretch. So we have a stretch of 3. And then see how we have x plus 1 here in the parentheses? So that means that our graph is going to be shifting 1 to the left. So we're going to say a stretch of 3 and a translation of 1 to the left. All right, guys, so this last bit is pretty short. So compounded equations. So if we have an equation that is compounded continuously, then we're going to be using the formula a to the t equals p times e raised to the power of rt. If we just have regular compounding going on, then we're going to use the equation a to the t equals a 1 plus r to the t. Remember that our rates, we need to write as decimals. All right, so if you don't do that, then you're going to get some funky answers. Just to let you know, the answer for number 12 and 13, number 12, you should have gotten 1,176, and for number 13, you should have gotten 5796. So just remember that if you are writing money, please make sure that you include the tenths and hundreds place, as well as the decimal point. We don't have $57.9, okay? And that's it.